CITS section 2.1 is on the two-dimensional coordinate system. Now most of this section should be pretty straightforward for you. We've done all of this before in previous classes. We talk about the coordinate axis, the XY axis. Just to give you the common or correct terms, the x-axis is called the abscissa, the y is the ordinate. You will very rarely hear it called that, it's just the x and y axis, but just to give you that information. Now, generally, quick review, we all know that if we have an xy coordinate, like 3, 1, I go from the origin, right 3, up 1, we find our location. Okay, or if I have -2, -4, I go back 2, down 4, and we have our location. Okay, now, most of these formulas are going to be things that you've done since Algebra 1 or Geometry. So you've had a few courses with them, but just a quick review. We use the distance formula, which is the distance between any 2 points. Okay, and those points are in terms of x and y. The distance formula is run as the difference between the x's squared plus the difference between the y ordinates squared, and then take the square root of that. Okay, midpoint formula, we have the average of the x's and y's. Again, the same points, point 1 and point 2, which are x's and y's. We average the x's and average the y's. So if I'm trying to find the distance between any 2 points, I'm looking basically at a right triangle. And I take the distance between these two and the distance between these two. Okay, and there's my distance formula. If I want the midpoint, I have the average of the x's and the average of the y's to get me halfway in between. If we're going to graph equations, we have a couple of different methods. One thing, tried and true method that always works, plot the points, make an XY table, plot a bunch of points and see where they go. The other method that we used in advanced algebra is we used what's called the parent graph. We take the parent graph and then shift that graph left, right, up, or down. And we'll go over a little bit more of that later in this chapter. Okay, but generally that parent graph there is a real quick way to get the correct graph. Okay. Lastly, we have the equation of the circles. Okay, our equation of the circle is done as x minus h squared plus y minus k squared is r squared. We know our center is h and k and our radius is r. We find that equation of the circle by completing the square usually twice. Okay, mostly we do it 2 times. And we'll do an example of that also. Okay, so I'll get on to our examples here. Number 18, just a real general formula. We want to find the distance between those 2 coordinates. Now again, we know our distance formula. Our distance formula is the difference of the x's, difference of the y's, both squared, and the square root. So I'm going to take the square root of x2 minus x1, and it doesn't matter which way you go on this, plus y2 minus y1. Okay, when I say it doesn't matter, this could be your x2 and that could be your x1. So you could flip them and it won't make any difference. Okay, simplify a minus a plus b plus a plus b minus b, and they're both squared. I end up with b squared plus a squared. And now remember, we can't simplify that. There's an addition sign in between them. I am going to write them in order, but we can't simplify them any further than that. Okay, 24 wants us to find the midpoint of the line segment with the given endpoints. To find the midpoint, again with our formula, midpoint is x1 plus x2 over 2, y1 plus y2 over 2. So take the average of the x points and the average of the y ordinates, and that gives you a coordinate. 4 plus -10 is -6 over 2 and 14 over 2. Simplify down, and we end up with -3 and 7. Okay, so all this I know is real old school for you guys. It's not a big deal. Find the second endpoint if the midpoint negative 2, 11, and one endpoint is 4, negative 6. Now this one you have to think a little bit more. If I want to find the other x endpoint, remember our general equation that the x midpoint is x1 plus x2 over 2. So if I take that, and the y midpoint is y1 plus y2 over 2. If I plug in what I know, the midpoint is negative 2. One of the endpoints is 4. And the midpoint of the y-coordinate is 11. And the endpoint is negative 6. Make that a little bigger. Now we just solve for what we don't know. Multiply by 2. Subtract 4. Multiply by 2. And add 6. And we should have our second endpoint of negative 8 and 28. Okay, so we just break it down to parts, plug in what we know, solve for what we don't. Now, these last three are to do with the equation of a circle. Okay, now they start with fairly simplistic. We know the equation of the circle is x minus h squared plus y minus k squared equals r squared. Okay, they want us to find the equation of the circle with the center at negative 2 and 5 passing through the point 1, 7. Now, if I do this, if I think about what's happening, I have a circle here. Its center is at negative 2 and 5. It goes through the point 1, 7, which means that the circle, that's on the edge of the circle. Okay? So I need the center, which I have. So I have x minus negative 2, which is x plus 2. Y minus negative 5, which is y minus 5. Remember that they're squared. Now all I need to do is find the radius. Well, the radius is the distance between these 2 points. Okay, so again, it's just how they give you the information. So if I use the distance formula here, I take the square root of x2 minus x1, 1 minus negative 2, squared, plus y2 minus y1, 7 minus 5 squared. Simplify, this is going to be 3 squared or 9. This is going to be 2 squared or 4. I get the square root of 13. Now we know that this is the square root of 13 squared, because that's r squared. So now we have all the information for our equation of the circle. X plus 2 squared plus y minus 5 squared equals 13. Okay, so not too difficult. We just have to translate what we know with the 2 points and realize that we need the distance formula to work our way between those 2 points. Now, this one gives us the same type of information, number 76, as the first, only again in a little bit different way. So find the equation of the circle with the center at negative 2, 3 and tangent to the y-axis. So let's get ourselves a little circle to look at. Okay, center is negative 2, 3. Now what does it mean to be tangent to the y-axis? Well, tangent means it only hits it at one point. So therefore what it means is that it looks something like this. Okay, if I'm tangent to the y-axis, that means if I come straight over, this turns into a right angle. So therefore, the point that I hit this at the y-axis has to be up the same distance as the center. So that tells me that that's 3, and the x-coordinate of the y-axis is always 0. Okay? So therefore, that tangent to the y-axis really tells me where that point is. So now it's the same type of problem as number 68. They just gave us the information in a little bit different way. So I know the distance between these two is 2. From negative 2, 3 to 0, 3. So I don't need the distance formula. I can go ahead and write the equation. X minus h is negative 2, so it's going to be x plus 2 squared. Y minus k, So y minus 3 squared is going to be the radius. The radius is 2 squared, which is 4. Okay. Now, last one. Last one wants us to find the center and radius of the circle given just the general form of the circle. Okay, it's not the graphing form. We call this one graphing form. This is the general form. Okay, so what we're going to do is we have to complete the square twice. So follow along. Remember, we went over completing the square back in chapter 1. So we're going to kind of follow along here. I'm going to separate the x's and y's. So it's x squared plus 3x plus y squared minus 6y plus 2 equals 0. Okay? Now I need to find the terms that will make these perfect squares. Okay, so to find my add-on term here, I take 3 over 2 and square it, which is 9/4. Okay, so I'm going to add 9/4 here, which means on this side, being on the same side of the equal sign, I need to subtract it. Okay, what I'm going to do though is I'm just going to add it to the other side. Because to get the general equation of the circle, I'm going to need to move that constant 2 over to the other side anyways. So I added 9/4 on the left side of the equation, added 9/4 on the right side. Now I'm also going to do the 6. Now it's b over 2 squared. Again, that negative is not really going to play much of a difference because if I square a negative or a positive, it's still going to be positive. So 6 over 2 squared is 3 squared, which is 9. So inside this one, I'm going to add 9. Out here, I'm going to add 9. Okay, so I'm going to rewrite this equation quickly. It's x squared plus 3x plus 9/4 plus the quantity y squared minus 6y plus 9 equals, I'm going to move that 2 over, negative 2 plus 9/4 plus 9. Now we just have to factor them. Remember, when we're factoring this, it's always the first term, or the x, the middle sign, plus, and whatever b over 2 was. So x plus 3/2 squared. This one factors as y minus, because the middle term was negative, and whatever b over 2 was, 3 squared. Now we have to add these up. I've got 9 and negative 2 is negative 7 plus 9/4. That's negative 28/4 plus 9/4, which gives us negative 19/4. Okay, let me check my numbers again here. Okay, so I've got my center. My center is the opposite of x, negative 3/2, the opposite of the term in there. So negative 3/2 and 3. My radius, let me double check these again. 9, let's see, negative 2, I've got negative 8/4 plus 9/4 plus 36/4. So that'd be 30, oh, it should be 37/4. So that's going to be equal to 37/4. As I take the radius then, that's the square root of 37 over 4. So the radius is the square root of 37 over 2. So my center is negative 3, or negative 3/2 and 3. My radius is the square root of 37 over 2. Sorry about the math problem there. I didn't bring my calculator with. Okay, so that's our general, what we need out of section 2.1. Easier problems, distance, midpoint. A little more difficult finding those equations of the circles. Okay, so try the homework, come with questions.